Hi, we're back. This is part 2 of the Arduino board tour extras. We're talking about things that were not mentioned previously in the rather high-speed tour of all the features of the Arduino board. In this video, we're going to talk about the various pins that weren't mentioned before. And because this has become a rather cluttered workspace, I'm just going to take that piece of paper away and put in a new, clean, fresh sheet of white paper so that I can annotate a few more than we'd seen before. I'm going to start by looking at the bottom edge of the board, and the first one that's kind of odd label you might see, and I'll just draw a fast outline again so that we can refer back to these by position in future if you're curious. First lower left pin is labeled IOREF. IOREF. And again, and I'm not to belabor the point, but that is the letter O. So we learned last time, or a previous video, we learned that O in this context, IO, is input, output. So input, output, ref is short for ref. What this pin does is a pretty particular job. This pin on the Arduino Uno and other Arduino boards is attached to 5V. It's directly attached to 5 volts. Well, that's kind of silly. So why would you have a 5 volts over here and then this thing with a different label that actually is also 5 volts next to it? Here's the reason. It's kind of for a designer, a future designer who's going to build something called a shield. A shield is an electronic thing that will fit down onto the Arduino, and it will plug into all these pins all at the same time. There's many different shields available for many different purposes, like a motor driver shield or a sensor shield or all sorts of them. But that shield is going to want to know what is the maximum voltage of this Arduino. So in order to find the maximum voltage of the Arduino, they give it this pin called IOREF, which is like a reference to the input-output voltage that it's going to be used, which in this case would be 5. But if this were not a 5-volt Arduino, if it were a 3.3-volt Arduino, then IOREF would put out 3.3 volts, and then the shield plugged in would know, aha, I should expect an on signal or a high signal to be 3.3 and an off signal to be 0. That's that pin. Next up is a pin labeled reset. So the reset pin is actually electrically attached to the reset button. So it's kind of this button and this pin do sort of the same thing. The way it works is you connect to ground to reset the Arduino. So let's imagine that you're building a project and the Arduino is inside of a box. And occasionally you might need to restart the Arduino. One way to restart it would be to unplug the power and plug it back in, but that could be a little clumsy. A better way to restart it would be to press the reset button, but the whole thing is inside of a box. You can't reach that button. In essence, what you could do is plug one end of a button into the reset pin and the other end of the button, the other wire coming out of the button, into ground. So whenever the button is pressed, it will connect the reset pin to ground. That will send the reset signal. Then that button could be on the outside of your box or in some place that's more easily accessible by the user. That's the reset pin. Next pin. Oh, and by the way, please note that it's an atypical or different kind of signal. When you connect reset to ground, that's when it's activated. That means like, yes, do that thing. So that's called active low in electronics. You might think of most things like you send them a high voltage signal to tell them to do their thing, and this pin is opposite that. The next thing we're going to point out is 3.3V, that is the label 3.3V. Well, you can probably get from its neighbor 5V what 3.3V might be. That is a 3.3 volt power supply. If you have something that you want to give a little bit of power to, it could be a sensor or all sorts of devices, might use a 3.3 volt standard instead of a 5 volt standard. The Arduino is able to supply a little bit of power at 3.3 volts to that thing. You would not want to run a motor or play some loud sound out of a speaker or do something that would use a lot of electricity, just a little bit of electricity to run a sensor. There are 6 pins here, which I will just draw like little 6 dots for to point those out. And if you watched the last video, you might have noticed that I referred to these 6 pins up here. It turns out these 6 pins, and they are noted on the board, it says ICSP. What that is short for is in circuit serial programmer. And these pins are connected directly to the Arduino brain, the main chip on the Arduino. What they allow you to do is program that chip without needing to go through the USB port. They can also be used for things. You can use those same pins to communicate with other things off the board. But basically, just pay attention to that programmer is kind of the clue you need to know. Send instructions straight to this chip without having to go through the computer, or rather, without having to go through the USB port. We have talked about pins 0 through 13. You know what the ground is. So there's still one pin left up here. It's labeled AREF, A-R-E-F. Sorry, there's 3 pins up here we're going to talk about. But AREF, come on, focus, is, you might see a kind of a similar nomenclature between IOREF and AREF. What that pin does, it's short for analog reference. And the use of that pin, we have these analog input pins in the lower right. Analog input pins can read a voltage between 0 and 5 volts, as if that thing is attached to a dimmer. So they could read a voltage like 1 volt, 1.3 volts, 1.37 volts, 4 volts, 5 volts. They could read kind of anything in that range. Though, you wanted to change the range that the analog input pins were reading from. So if you had some knob and you know the highest that knob can go is 2 volts, you still want to read from 0 to 2 volts with a lot of precision or resolution, then what you can do is connect 2 volts to the AREF pin. What that will do is change the ceiling, the highest possible voltage that these pins are looking for. It's not very common application. That's what it does. There's 2 more pins to talk about. They're not labeled here on the board. They're only labeled on the side in that paint up there. And your board may not have those labeled or may not have them at all. This varies. I've seen it vary fair bit between different manufacturers. So what these are, SDA and SCL. I'll just draw my arrows. It's SDA on the right, SDA, and SCL. What SDA is short for is serial data. CL is short for is serial clock. Those are 2 pins that can be used to communicate with other devices, with other Arduinos, or with other things. So, for instance, a GPS module, which is going to read GPS signals and report the location, the current location of the Arduino, may plug in through the SCL and SDA pins. Or a sensor, let's say a magnetic field sensor, might use those pins. So a whole variety of devices can talk with the Arduino, and it's 2-way communication through that thing. When you are using those pins, you're using what's called the I2C communication protocol. I2C stands for integrated circuit. And here's something that's kind of important to know. If you are using SCL and SDA up here in the upper right corner of the board, or I guess upper right from that perspective, upper left from this perspective, is that SCL and SDA, those pins are the same pins as A4 and A5. And I remember off the top of my head which is which, but let's just say SCL is maybe A5 and SDA is A4. So that means, similarly to pins 0 and 1, the communication pins, if you have stuff plugged into A4 and A5, you may accidentally interfere with serial communication using I2C, using those pins. So be careful about that. It's a little caveat to keep in mind. That wraps up this extended version of the Arduino board tour. Thanks for sticking around for all that extra detail. I hope it was interesting.